Hello, welcome everyone to this new video, and in this video I am going to talk about virtual hosting, and very specifically we are going to talk about name-based virtual hosting. So if you are thinking what is name-based virtual hosting? So the name-based virtual hosting allows us to share multiple websites on a single IP. You can host multiple websites that shares the same single IP. Now what does this even mean? So let's move on to the next slide, and then we see with a quick activity. As you can see on the screen, we can see there are 4 domains here: expiredbadssl.com, wronghostbadssl.com, self-signedbadssl.com, and untrustedrootbadssl.com. After this activity, we will see that all these 4 websites resolves to the single IP. So this is the entire idea of the virtual hosting, where the single web server can host multiple websites using a single IP. So let's quickly check it out with our activity. So we are going to open the command prompt. In this one, we are going to check using ns lookup command. If some of you don't know, ns lookup command can be used to resolve domain to IP, as you will see this in a short while. So let's put the domain here, expired.badssl.com, and you can see on the screen it resolves to 104.154.89.105. Let's check it out for next domain. The next domain is wronghostbadssl.com, and it again resolves to the same IP, 104.154.189.105, as you can see on the screen. Let's move on to the next website, that is self-signed.badssl.com, and you can see the IP remains the same, 104.154.89.104. Lastly, let's check this last domain as well, untrustedroot.badssl.com, and the IP is again same, 104.154.89.105. So as you can see on the screen, we have run the ns lookup command on 4 different domains, but every time it resolves to the same single IP. So I hope by this time it is very clear to you that virtual hosting, in fact the name-based virtual hosting, means that the web server can host multiple websites on the same single IP. Let's move on with our lecture. But why virtual hosting was needed? What was there even a need at the first place to host multiple websites on the same single IP? So the first point, as you can see here, was related to the web growth. As the internet exploded exponentially at the start of 2000, everyone needed an efficient way to host multiple websites on a single server. It had to be cost effective, and that led to the design of name-based virtual hosting. The second thing was the limited IP version for address, because if you know that IP version for address follow a 32-bit namespace, and 2 to the power 32, if you do, then it comes to somewhere 4.3 billion IP version for address. But again, most of the IP address in this block is reserved for some other purpose. So the IP address that is left for the public use is already less than 4 billion. Third one is resource scarcity. As you just mentioned, there was not enough unique IP for every website. So the exponential increase in the web growth, limited IP version for address space, and the resource scarcity led to the design of name-based virtual hosting. So how the name-based virtual hosting work in HTTP connection? So this is when I say HTTP connection, it is unencrypted connection, unencrypted network. Okay, as a web server we can host multiple websites, but as a client, so suppose this is a client and this is the server behind which 4 websites are sitting here. So how does client even know that how to reach website 1, website 2, website 3, website 4, and that's what we are going to talk about now. So what happens when a client types a domain? You types the domain, so suppose example.com. Then once the user types the domain in the browser, from domain to IP resolution works. So client is able to reach to this server here. Now browser connects to the server IP address, as you can see just now we discussed. Then third thing is the HTTP request sent using the host header. One of the important thing to understand is that any HTTP connection host header is very important. So if you know, or I can show you just in a while, whenever you send a connection between client to the server, first TCP handshake happens. After the TCP handshake is over, then application data is sent, and it is in the application data that the client sends the host header, and it is the most important concept behind the working of the name-based virtual hosting. So when the HTTP request gets initiated, request includes the host header, as we will see in a while, and then the server routes, means the server routes the request based on the host header. So if the host header includes website 1, it will send to website 1. If the host header includes host as website 4, it sends to website 4, as I will show you quickly here. I already have, so all the 4 domains that we just saw in the previous exercise, I have already put it in the Postman. So what I will do is that I will initiate the connection from my Postman client to the web server, like expiredbadssl.com, as you can see on the screen in the console. So this is the console. I triggered HTTP request to expiredbadssl.com. If you open it, then as you can see here, host. So every time an HTTP connection to the server is initiated, you will find this host header by default included there. If you go to other website, wronghostbadssl.com, then you will see the similar information. badssl.com. When you try the same thing on, now we have tested expiredbadssl.com, wrongbadssl.com. Let's try self-signedbadssl.com, and let's see what is the host header inside this self-signedbadssl.com. So as you can see, every time you initiate a HTTP request to the server, the host header will always be included, and the server routes the request. So basically server uses this host header to serve the correct website. So you know, the concept of host header is so much important in any integration, any API integration that you do, because I'm again from the integration background, so I'll bring back to the actual use case that you do. That whenever you are trying to pull a website, the content of the website, you initiate the HTTP request, host header is included. On the server side, the server sees the host header and serves you the content from the proper content corresponding to that website. In an API integration, if you initiate connection to the server, if the server is hosting multiple websites, initiate a connection, the HTTP client includes the host header, the server reads that host header, serves you the content, or it routes the request back to the original backend where the request is supposed to go. So now you know what is virtual hosting, why virtual hosting was required, how the virtual hosting works in HTTP connection. If you want to understand with real life analogy, then let's take example of the apartment building, which is very common, and it is perfect example, I believe, to understand the virtual hosting. So let's see here. Suppose that you need to deliver a letter to a flat or a unit in a building, right? First, to reach there, you need the building address. In the internet world, IP address is corresponding to the building street address. You need to go to a particular unit in that building. So first you find the building address. In internet world, it is IP address. You go there. From after you reach that building, then you have to go to the individual apartment. So but that building is hosting many different units, many different flats. Just like a web server on a single IP can host multiple websites. Then after you go there to the building, then you check what is the apartment number, and then from basically you go to building, there are many units. From these units you see what is the apartment number, then you reach the particular apartment. In the internet world, the HTTP request is sent to IP address. This IP address hosts multiple websites, and then you look at the host header to reach the proper backend. I hope this concept gives you a clear understanding of name-based virtual hosting and the importance of host header. Now, but in the real world is moving from HTTP to HTTPS, that is secure HTTP. So what is this HTTPS challenge? So in the previous one we just discussed that client sends connection to the server looks at the host header, and then it serves you the website. But in the HTTPS connection, you know that the host header is encrypted, and server cannot understand this host header without completing the TLS handshake. But to do this TLS handshake, so as you can see here, encryption first. In HTTPS, the data is encrypted. TLS handshake happens before HTTP request is sent, and for TLS handshake to happen, the server has to find the proper certificate against the domain. Server should be able to choose the correct certificate for the domain that you are trying to visit. But we just discussed host header is encrypted. So how server will know which site certificate to use during the TLS handshake? And this entire HTTPS biggest challenge to the virtual hosting. Basically, virtual hosting was breaking because of this HTTPS deployment, and this gives birth to the concept of SNI, that is also known as server name indication. And in the next video I am going to discuss about SNI, which is a wonderful concept in the case of virtual hosting and HTTPS world. But before I can even discuss SNI, I think it is important to discuss TLS handshake, because TLS handshake is very important to understand, and that's where the SNI comes into picture. So before I explain you the SNI and how does SNI work in the virtual hosting and HTTPS world, I'll talk about the TLS handshake, and I will see you in the next video. But hold on, there is an additional surprise. It is just like I just quickly wanted to have, like, I'm going to discuss TLS handshake in detail later, but it is important to give you a brief highlight of what happens during the TLS handshake between the client and the server is. So suppose there is a client and the server we just discussed. Whenever client talks to server, right, then there is always first TCP handshake happens. It happens in HTTP connection also. This happens in HTTPS. After TCP connection is established, and if it is HTTPS implementation, then the TLS handshake happens. After TLS handshake is successfully finished, then the application data is sent. So you need to understand, I'm not going to discuss about TLS handshake, but you must understand that in any HTTP call, HTTPS call, first TCP handshake happens. If this is successfully completed, native TCP socket is opened between the client and the server, then TLS handshake happens. After TLS handshake is successfully over, then the application data is sent. Okay, I hope this video would have provided you some additional information and it would have been helpful to you. And if you like my video, you can subscribe to my video to get more updates about the new video when I release. Thank you so much. I will see you in the next video with TLS handshake and SNI. Thank you so much.